The frozen landscapes of North America stretched endlessly before them, vast, merciless, and unforgiving. Winter temperatures plummeted to levels that would kill an unprepared person within hours. Winds howled across open terrain with enough force to knock a person down. Snow accumulated in drifts taller than a standing adult. Yet for millennia, indigenous peoples not only survived these conditions, they flourished in them. How did they achieve what seems impossible by modern standards? Living through winters that would challenge even our contemporary technology, these cultures developed survival methods so sophisticated that they deserve recognition as some of humanity's greatest engineering achievements. Their approach wasn't about brute force resistance against nature's fury. Instead, they developed an intricate understanding of thermal physics, material science, and environmental adaptation that allowed them to transform winter itself into an asset rather than an adversary. This represents a fundamentally different philosophy than our modern approach. Where we combat cold with expensive energy consumption, they worked alongside natural principles. Their innovations revealed that survival depends less on technological complexity and more on deep observation and creative problem-solving. Stay with us as we explore the remarkable techniques that kept entire civilizations warm when temperatures dropped to deadly extremes, and discover engineering principles that remain astonishing even by contemporary standards. Here's something that might surprise you. The indigenous approach to winter survival focused primarily on heat retention rather than heat generation. They grasped a fundamental truth that modern thermal engineers confirm: motionless air ranks among nature's finest insulators. Their brilliance lay in discovering natural materials capable of trapping maximum air volume within minimal space. They constructed elaborate layering systems where each component served a distinct purpose, creating pockets of trapped air throughout. This represented natural thermal engineering functioning at a remarkably sophisticated level. Among their most extraordinary materials was cattail down, harvested from wetlands and riverbanks. This feather-light, silky substance possessed insulating characteristics rivaling modern synthetic materials. Indigenous peoples stuffed it into footwear and garment linings, creating protection that weighed almost nothing while providing exceptional warmth. Dried grasses and mosses served as another crucial resource. These materials were packed between clothing layers and within dwelling walls. The hollow structure of grass stems formed innumerable tiny air chambers that prevented cold air circulation. This renewable, accessible material literally surrounded them everywhere they looked. Animal hides were utilized with remarkable sophistication. The importance extended beyond just the fur. Properly processed hide created a wind-blocking barrier. Combining wind-resistant outer hide with fluffy inner fur or other insulation produced optimal protection against the elements. Even snow, paradoxically, became their thermal ally. They recognized that freshly fallen snow contains enormous amounts of trapped air, making it an excellent insulator. They constructed high snow barriers around dwelling foundations, blocking wind and preventing heat escape through lower wall sections. This conservation-focused philosophy permeated every aspect of their existence. It demanded careful observation, remarkable patience, and profound respect for nature's offerings. Each element of daily routine formed part of a unified, meticulously planned energy management system. They didn't attempt to defeat winter through confrontation. Instead, they became integrated with it, utilizing its fundamental laws for their own benefit. This created an invisible protective barrier, woven from air, plant fibers, and snow that reliably shielded them from the most severe cold. The nomadic teepee appears deceptively simple at first glance, just poles and animal hides arranged in a cone shape. Yet this elegant structure represents centuries of refined engineering, perfectly calibrated for harsh plains environments. The conical design provided extraordinary wind resistance. Even gale-force winds simply flowed around the structure rather than pressing against vulnerable flat surfaces. The slightly backward-leaning angle further enhanced stability, anchoring the entire assembly firmly to the ground. The framework consisted of 15 to 20 long, straight pine poles. Erecting this required considerable skill. 3 or 4 primary supports were bound together, with remaining poles arranged in precise sequence. This created a robust skeleton capable of supporting heavy coverings and substantial snow loads. The exterior covering required 12 to 20 buffalo hides carefully stitched together, weighing over 100 kilograms when complete. Properly prepared hides became nearly waterproof and entirely wind-resistant, critical qualities for exposed prairie environments. But the teepee's true thermal genius existed inside, an interior liner made from thinner processed hides attached to the poles, suspended approximately half a meter above the ground. This created an air cavity between outer and inner walls, functioning like a primitive thermos. This liner served another vital function. Cold air seeping beneath the outer edge didn't blast into the living space as an icy draft. Instead, it traveled upward through the gap between skin layers, mixing with warm air from the central fire and creating controllable ventilation. The fire pit was positioned slightly off-center toward the entrance, a deliberate design enabling efficient smoke evacuation through the top opening. This smoke hole featured 2 adjustable flaps that regulated draft and protected against precipitation. Flooring consisted of hides and sometimes dried grasses, providing ground insulation. Sleeping areas ringed the perimeter, often on small raised platforms or thick fur layers. People positioned themselves feet toward fire for even heat distribution throughout their bodies. The entrance always faced eastward, protecting the dwelling from prevailing western winds. The low, narrow opening featured a hide curtain that minimized heat loss during entry and exit. The teepee wasn't merely shelter, it was a complete climate control system. It preserved warmth, ensured ventilation, and blocked wind while remaining entirely portable. This unique combination made it ideal for the nomadic plains lifestyle. In northeastern North America, where dense forests met long, brutal winters, with temperatures reaching -30 degrees Celsius, the Iroquois Confederacy developed an entirely different architectural solution. Rather than mobile conical shelters, they constructed permanent longhouses serving as dwelling, social center, and thermal hub for entire extended families, sometimes housing dozens of individuals. These impressive buildings measured 20 to 60 meters in length and 6 to 8 meters in width. They featured sturdy frameworks of young elm trunks bent into graceful arches, creating vaulted tunnel-shaped roofs remarkably resistant to heavy snow accumulation. The wooden skeleton was completely covered with large elm or ash bark sheets, layered in overlapping fashion like modern roofing tiles. Bark provided natural waterproofing and insulation, abundantly available at no cost from surrounding forests. The longhouse's thermal efficiency derived partly from scale and communal living. Up to 20 related families, potentially 100 people, might inhabit a single structure simultaneously. The metabolic heat naturally produced by dozens of breathing, moving bodies became a significant supplementary heating source. This represented a living, self-warming organism that generated internal heat through collective biology. Each person produces roughly 100 watts of heat. 100 people provided 10 kilowatts of continuous heating without consuming any fuel. Along the central corridor, multiple hearths were strategically positioned several meters apart, typically 3 to 10 depending on building length. Smoke rose naturally, escaping through ventilation openings in the roof that could be adjusted with movable bark panels for draft control and weather protection. This distributed system maintained fires at multiple locations, evenly distributing warmth throughout the entire structure without creating cold zones. Each family accessed their own hearth, but collectively they formed a unified heating network. Family quarters were organized systematically on both sides of the central passageway. Each family occupied approximately 3 meters of width, functionally divided into 2 vertical levels. The ground level served for daytime activities, cooking, tool maintenance, socializing. The upper level consisted of wide wooden platforms elevated 1 meter, used exclusively for sleeping on furs and blankets. These raised sleeping platforms represented critical thermal engineering. They elevated occupants above the coldest air accumulating at ground level due to convection. Additionally, warm air from burning hearths rose and concentrated beneath the vaulted roof, naturally warming those sleeping on upper platforms. Walls were deliberately multi-layered for maximum insulation. Interior surfaces were often covered with woven cattail mats or animal hides around the entire perimeter, creating additional insulating air layers between bark and living space, effectively blocking drafts penetrating through inevitable exterior cracks. Food supplies, corn, beans, squash, firewood, were stored inside the structure in special vestibules or on high shelves beneath the roof. This protected strategic reserves from weather and pests while creating significant thermal mass that stabilized interior temperatures against sudden fluctuations. Entrances featured carefully designed vestibules functioning as airlocks. They often had deliberately complex shapes or exterior woven screens that created buffer zones, physically preventing icy wind from rushing directly into living space. The Iroquois Longhouse wasn't just a large wooden building. It was a carefully engineered, self-sufficient living ecosystem, ingeniously combining architectural solutions, social organization, and daily practices into a coordinated survival mechanism for harsh climates. The fundamental secret to cold weather protection isn't thickness. It's the strategic combination of multiple layers. Indigenous peoples perfected this principle, creating clothing systems that were warm, lightweight, breathable, and unrestricting. The foundation was layering. Instead of one heavy garment, they used several thinner ones. Air trapped between each layer provided natural insulation. The innermost layer consisted of thin, soft suede, deer or antelope hide, processed to fabric-like texture. This material felt comfortable against skin and effectively absorbed moisture, wicking it away from the body. Critically important, since wet skin freezes far faster than dry. The middle layer comprised basic garments, shirts, leggings, dresses sewn from thicker processed leather. Loose-fitting designs didn't restrict movement and created additional airspace. Outer garments consisted of spacious robes sewn from whole buffalo hides with fur facing inward. Long, thick fur created powerful insulation, while smooth exterior leather provided excellent wind protection. These versatile robes functioned as daytime protection and nighttime blankets. Footwear received special attention since feet contacted cold ground constantly. High moccasins were constructed from multiple leather layers. Interior insoles made from dried grass or fur provided additional insulation and moisture absorption. Winter moccasins were intentionally oversized, allowing multiple fabric or fur sock layers plus space for additional insulation, often cattail down or rabbit fur. Mittens sewn from furred leather protected hands. Unlike gloves, mittens kept fingers together, allowing mutual warming, a simple solution providing far more effective heat retention. Heads were protected by hats made from beaver, otter, or similar thick furred animals. Many featured ear flaps deployable during strong winds or severe frost. This entire system was dynamic and easily adaptable. During physical activity, outer layers could be removed to prevent overheating and sweating. During rest or extreme cold, additional wrapping provided extra protection. Across the Great Plains, forests were scarce or entirely absent. Finding firewood for daily heating and cooking proved virtually impossible. This fuel shortage forced nomadic tribes toward an ingenious, inexhaustible alternative: dried buffalo dung known as buffalo chips. Massive herds numbering in the millions left countless amounts of this valuable material. For Plains inhabitants, it represented genuine treasure. Collecting dung was important daily work, primarily performed by women who stored it in special containers. Collected material was brought to camp and sun-dried thoroughly. Completely dried buffalo dung consists of dense, fibrous mass, mainly digested grass. It burns slowly and evenly, producing substantial heat while generating minimal smoke. This quality proved especially valuable, as acrid smoke inside a teepee would create serious problems. Smokeless combustion also aided camouflage. A camp with numerous such fires remained virtually invisible from distance, advantageous both for hunting and defense. The aroma of burning buffalo dung was distinctive but not unpleasant, described by witnesses as resembling dry grass. For people raised on the prairie, this scent meant home comfort. Fuel efficiency was remarkable. A small pile maintained fire for several hours, allowing economical supply use and reducing gathering time. This usage formed part of a waste-free plains life cycle. Buffalo provided nearly everything: food, clothing, shelter, and fuel. An ideal system fully integrating humans into their ecosystem. Winter supplies were stockpiled extensively. Large piles of dried dung were stacked near teepees, sometimes covered with hides for snow and moisture protection. Native American winter survival didn't depend on a single miraculous invention. It represented a comprehensive, multi-level system combining ingenious engineering with profound natural understanding and wise social organization. From teepee aerodynamics to clothing thermodynamics, from buffalo chip utilization to snowdrift architecture, each element was refined across centuries, working in complete harmony. They proved that comfortable living doesn't always require complex, energy-intensive technology. Sometimes observation, ingenuity, and resourcefulness with nature's own provisions suffice. Their legacy transcends fascinating history. It offers inspiration and wisdom increasingly relevant today amid environmental challenges. Which ancient survival principles might we apply to modern life? Share your thoughts below and subscribe for more explorations of ancestral wisdom.